Question number 2 deals with what? What is moment of inertia? Complete question is, what is moment of inertia, factors on which moment of inertia depends, and what is the physical significance of the same? First part. Question number 2, A part. Its first part is moment of inertia. Moment of inertia I is equal to what? Sum of mr square. How you define this? Yes, sum of what? Products. Yes, this is sum of product of mass into square of perpendicular distance. R is perpendicular distance from axis of rotation. So, first part deals with what is moment of inertia. So, the definition is, moment of inertia is defined as a sum of products of masses of all the particles of the body and the square of their respective perpendicular distance from the axis of rotation. Moment of inertia depends on yes, first, it depends on position of axis of rotation. Position of axis of rotation. Example. Object 1, 1 kg. Object 2, 1 kg. Axis of rotation R1, 1 meter. R2, 2 meters. Find moment of inertia in this first case. Leave 3-4 lines for this part. Then write moment of inertia depends on point number 1, position of axis of rotation. Here, I may call this as axis of rotation, this one, AB. So, find moment of inertia of this object about AB. 2 minutes with you to try. M1 R1 square plus M2 R2 square. M1 is how much? 1 square plus M2 1 kg, R2 2 square. Total comes out at 5. This is 1. And now, if I ask you to find moment of inertia about an axis passing through M1, that is, now we change this question, masses remain same, and now I ask you to find moment of inertia about an axis CD. Moment of inertia about CD. M1 is at what distance? 0. M2 is at what distance? 1. So, M1 R1 square plus M2 R2 square. M1 is how much? 1 kg into 0 square. M2 1 kg into 1 square is equal to 1. First case it is 5, second case it is 1. Why it is different? You have changed axis of rotation. First case was, it was a dumbbell and axis of rotation about this. Second case, again a dumbbell and axis of rotation passing through one of the masses. So, in one case it comes out to 5, in the other case it comes out to be 1. So, point number 1, it depends on what? Position of axis of rotation. 2, It depends on what? Orientation of axis of rotation. Again, an example. Only one object, mass 1 kg, distance r 1 meter. Find its moment of inertia about AB. Yes, how much? Mass m, r square. M is 1, r is 1, so the answer is 1. Find moment of inertia about another axis CD. Find moment of inertia about another axis CD. Angle is 45 degree. Do it. Moment of inertia about CD. Yes, anyone? This distance is 1. What about this one? Perpendicular distance. Go through the definition. Moment of inertia is sum of product of mass and square of a perpendicular distance from axis of rotation. And the perpendicular distance in this case, let me say, is y. Y by r is equal to sine 45. It is r sine 45. 1 into 1 by root 2. So, it is not m into r square, now it is m into y square. M is how much? 1. Y is 1 by root 2 square. So, the answer is 1 by 2. Why the answer has changed? Earlier the moment of inertia about this axis. If you change the orientation, then the moment of inertia will also change. 3. Depends on what? Point number 3. It depends on what? Shape of the body. 3. It depends on shape of body. Different shape, formula for moment of inertia will also be different. Ring. For a ring, moment of inertia I is equal to mr square. For a disc, we will prove in question number 3, 4, 5. For a disc, moment of inertia is 1 by 2 mr square. For a sphere, it is 2 by 5 mr square. For different bodies, shapes, it is different. 4. Size of the body. Yes. Size of body. Cricket ball, small object, mass is small, radius is small, value will be small. Earth, both are spheres, but the moment of inertia of Earth is more because mass is more and radius is more. Last, distribution of mass of the body. Distribution of mass of body from axis of rotation. If mass is close, nearby, moment of inertia is less. If mass is away, at a distance, moment of inertia is more. Time with you is 3 minutes to complete. 3 minutes to complete. And before you take up the next part also in the same, one more line is written. What is the physical significance of this? What is the physical significance of moment of inertia? In the same question we cover 1 by 2 mv square is linear, 1 by 2 I omega square is rotation. Whatever was the significance of mass in a linear means if you have a cycle and a truck, it is difficult to start or stop a truck because truck has more inertia, more mass. Similarly, if the rotating object has more inertia, it is difficult to rotate, or if it is rotating, it is difficult to stop. Time with you is 3 minutes. B part deals with what? Units, dimensions, whether it is a scalar quantity or a vector quantity. First part, SI units. Yes, mass, kg, distance, meter, kilogram, meter square. Dimensions, kg, mass, m1, meter distance, length square, time, 0. Third, whether it is a scalar, vector, yes, it is a tensor, neither scalar nor vector. For a scalar quantity, for example, this object, if I ask what is the mass of the object, say 100 grams. So there is no other question in which direction, there is no sense to this question in which direction. So it is a scalar quantity. If I ask you where is the bus stand, you say 2 kilometers. Then I ask another question, in which direction? Then you answer what? In this direction, in this direction, in this direction. You point out in space. When you point out in space, it is vector quantity. But here, if I ask you, what is the moment of inertia of this? There is no answer to this. You have one more supplementary question about which axis. Moment of inertia about this axis is different. 1 by 12 ml square. Moment of inertia about this axis 1 by 3 ml square. So again I ask you, what is the moment of inertia of this object? There is no answer to this. You have a supplementary question about which axis. If you have such supplementary question with you, then such a physical quantity is termed as tensor. So moment of inertia is a tensor, neither scalar nor vector. 2 minutes to write. 2 minutes to write. One numerical based on the same. Three masses, each of mass m. You need not refer to the book. Each side is L. This is XA, axis XA. It is an equilateral triangle, all sides LLL, all angles 60 degree. It's in the book, it is numerical number 15, you need not refer. Find moment of inertia about AX. Time with you is 2 minutes. Yes, moment of inertia is what? This mass m. It is at what distance from axis of rotation? Anyone with the answer, please? Anyone? Correct answer. This is at what distance? 0. M into 0 square plus the second object. It is at what perpendicular distance from axis of rotation? L. So it is m into L square plus third object, this one, perpendicular distance. This distance is, yes, this is center. This distance is how much? L by 2. So this distance is also L by 2. So perpendicular distance from the axis of rotation is L by 2. It is m into L by 2 square. So the answer is 0 plus ml square plus ml square by 4. This is 1. 1 plus 1 by 4. 5 by 4 ml square. So moment of inertia 5 by 4 ml square. In the expression moment of inertia, it was sum of m into r square, where r is perpendicular distance. R is perpendicular distance from axis of rotation.